Good afternoon, my dear students. Today we're going to have another virtual class for Math 6103. This is Calculus 2. Today we're going to discuss your limits on Continuity 1, which is under Module 4, Week 3. So we have here the limits and Continuity 1. At the end of this session, students will be able to 1. Define a tangent line and a second line. 2. Use the average rate of change formula. 3. Understand the limit. And 4. Find the limit of a function. So first, we're going to have the tangent lines and rates of change. In this topic, we're going to take a look at two important problems in the study of calculus. These problems will lead us into the study of limits. First, this problem will allow us to understand what a limit is and what it can tell us about a function. Secondly, the rate of change problem is one of the most important concepts that we'll encounter in calculus. So first, we have the tangent lines. What is a tangent line? The first problem that we're going to take a look at is the tangent line problem. Before going to this problem, it would probably best to define a tangent line. So what is a tangent line? A tangent line to the function f of x at the point x is equal to a is a line that just touches the graph of the function at the point in question and is parallel in some way to the graph at that point. So we have your figure 1, which is the graph of the tangent line and the second line. So this is our slope and this is our graph, which is a function of x. So if this is our point of 1, your point 1 here is the point of tangent C. Kaya sabi niya, we got a tangent line. Okay? So when we say tangent line, we have a line just touches the graph and the line is parallel to the given graph. Okay? If this is your point 2, sabi niya, not a tangent line here. Dahil, pag titignan po natin, yung graph natin is not parallel with the line. It is perpendicular. Okay? Kaya sabi niya, not a tangent line. At the second point shown, the point where the line is not a tangent line, we sometimes call the line a second line. Okay? As defined earlier, a tangent line is a line that touches a curve at one point. Here are some of the example. So we have the ellipse, no? Tapos yung tangent line po natin, it touches the curve, and this is now your point of tangent C. And the line is parallel to the graph or to the curve. Dito, ganun din po siya, no? This is our point of tangent C. The line is parallel. The same at this point, parallel din po siya. The same din dito. It's also parallel. Okay? So, figure 2, that's now the example of the tangent lines. And this one, you have now the point of tangent C, and the line is parallel to the curve or to the graph. Okay? Next, what is the second line? A second line is a line joining 2 points on a curve. Here are the example of the second line. So, this is your x and y axis. This is our slope. And this is our graph. Okay? And the point of tangency dun sa slope po natin ay dalawa. This is the first one. And this is the second one. So, joining 2 points on a curve. Ito po yun. Kaya tinawag nilang second line. Pero pagdating sa tangent line, yung point of tangency niya is isa lang po siya. Pero sa second line, dalawa. Okay? So here are another example. Example of the second line, ito meron tayong dalawang point of tangency. Dito dalawa rin, no? Yun ang point of tangency nila. So ang tawag po dito, that is now the slope of the second line. Wherein there are 2 points of tangency doon sa graph po natin. So next, we have the rate of change of a second line or the slope of the second line. So we're going to consider the second line. The shore x and y axis, we have your d slope, and the shore curve, okay, y is equal to the function of x. By this time, your line dito is what we call the second line. At point 1, we have your x1, project it upward, kung saan po yung intersection po niya, and then project to the left, we have your d, the function of x1. At this point of the intersection, these are your coordinates, x1 and fx1. So wala tayong y1, no? Kasi dati, sabi niya dito, y is equal to the function of x. So y1 is equal to the function of x1. And also, we have your x2. Project it upward, project it to the left, then we have your y2, which is the function of x2. The coordinate here is x2 and the function of x2. Okay? So, delta y is equal to y2 minus y1. Magmula dito hanggang dito, okay, that vertical distance is what we call your d delta y. Or, that's what we call the rise. No? Magmula dito, yung vertical distance nila between the 2 points sa x, ang tawag po natin doon is what we call the run. Okay? This is your x2, x1, we have your d delta x. That is your run, no? Or, h is equal to x2 minus x1. Figure 4 represents the slope of the second line. So, yun po siya yung slope ng second line po natin. Next, we have our formula. M is equal to delta y all over delta x. From our geometry, this is our formula for the slope. Where your delta y, that's your rise all over run. Well, delta y is equal to y2 minus y1. Delta x is equal to x2 minus x1. But by this time, wala tayong y2 at saka y1. Wherein your y is equal to the function of x. So therefore, y2 is equal to the function of x2. y1 is equal to the function of x1. So delta x is equal to x2 minus x1. So with that, this is our formula. M is equal to the function of x2 minus the function of x1 divided by delta x. It's also the same as the function of x2 minus the function of x1 divided by your h. Okay? So ito yung h po natin. Same pa rin na x2 minus x1. As stated earlier, the slope of the second line represents an average rate of change between the 2 points graphically represented by the shown figure with the formula. So, average rate of change, that is our slope, is equal to f x2 minus f x1 divided by x2 minus x1. So, we have your example number 1. Find the average rate of change for the function and the interval. Function of x equal negative 2x squared plus 4 at 1 and 4. Sabihin, this is now the equation of our graph. Okay? So, solution, the average rate of change equal to your m, the function of x2 minus the function of x1 divided by x2 minus x1. We're going to look the given 1 and 4. Karamihan po kasi, kung meron tayong nakitang ganyan, This one represents your x and y coordinates. Pero dito, hindi siya x and y. Your 1 represents your x1. Yung 4 represents your x2. Okay? So we're going to have that one. The function of x2 is equal to 4. Function of x1 is equal to 1 divided by x2. 4 minus x1 is 1. Is equal to, paano nagkaroon tayo ng negative 28 sa negative 2? Dito po siya, no? If we're going to substitute yung x2 po natin, which is 4, from our equation, 4 squared is 16 times negative 2, we have negative 32. Plus 4, kaya nagkaroon tayo ng negative 28. Next, the function of x1 is equal to 1. 1 squared is 1 times negative 2 is negative 2 plus 4. So the answer is 2. 4 minus 3 is equal to 3. So negative 28 minus 2, the answer is negative 30 all over 3, or that is equivalent to negative 10. So that is your m, the slope of the second line. Okay? Next, we have your another example. Find the average rate of change for the function and the interval. The function of x is equal to second x, then our point is equal to 0, pi, and 3. So, we know that from our trigonometric functions, second x is the reciprocal of 1 all over cosine x. So, ibig sabihin, pareho lang sila. Again, this is our x and y coordinates. 0 represents your x1, pi all over 3 represents your x2. So, we have our solution. The average rate of change for the second line is equal to your m, the function of x2, minus the function of x1 divided by x2 minus x1. Okay? By this time, your x2 is equal to pi all over 3, x1 is equal to 0. Then, we have x2 pi all over 3 minus 0. So, if we're going to substitute this one in our given equation, f of x is equal to 1 all over cosine x. Kaya we have 1 all over cosine pi all over 3 minus 1 all over cosine 0 divided by pi all over 3. Okay? So, if we're going to look on our given data, pi all over 3 is in terms of radians. So, what we're going to do, we're going to convert radians into degrees. So, our conversion there is that pi radians is equivalent to 180 degrees. And if we're going to convert this one, we have 180 divided by pi radians. So therefore, pi and pi radians are going to cancel. What's left will be 180 divided by 3, or that is equivalent to 60 degrees. Okay? So if we're going to make use of your calculator, cosine 60 degrees is equivalent to 0.5 or 1/2. Ito na po siya. So ito yung value ng cosine pi all over 3. In terms of degree, cosine 60 degrees, that is 1/2 or 0.5. And also, we know that cosine 0, by using your calcu, that is equivalent to 1. So 1 divided by 1 is 1. Next, we have your divisions of fractions. So for division of fractions, what we're going to do, invert the fractional divisor and then proceed as in multiplication. So 1 divided by 1/2 is magiging 2 times 1. We have 2 divided by 1. We have 2. Then minus 1. Then we have pi all over 3. 2 minus 1 divided by pi all over 3. So we have 1 divided by pi all over 3. Again, divisions of fractions. So your answer will be 3 all over pi. If you're going to have your calcu, we have 0.9549. So that is now the slope of the second line applications. Next, we have now the instantaneous rate of change or the slope of the tangent line. So what's now the difference between the slope of tangent line and a second line? Ito po siya. What we want to do here is determine just how fast f of x is changing at some point in x. This is called the instantaneous rate of change, or sometimes just rate of change, or f of x at x is equal to x. So if we're going to look on our formula before, dalawa yung formula po natin. So yung unang formula and yung unang formula para sa second line. So yung pangalawang formula and yung formula ng slope for the tangent line. So yan yung first difference mo nila. Kaya sabi niya, then to estimate the instantaneous rate of change at x is equal to h, ang gagawin lang po natin, all we need to do is to choose values of x getting closer and closer to x is equal to h. Dapat malapit lang po siya. Bakit po? When you say tangent line, we have only one point of tangency. And at the same time, the line is parallel. Kaya pag titignan po natin dito, dun sa drawing po natin, yung point of tangency po natin, ibig sabihin, maliit lang po siya. Di tulad sa second line, meron tayong 2 points. Sa tangent, wala po tayong ganon. Kaya, sabi niya, dapat yung value ng x natin is getting closer and closer to x is equal to h. Don't forget to choose them on both sides of x and compute values of average rate of change. From that, we can then estimate the instantaneous rate of change. Okay? So ito na yung ano natin, no? Pag sa second line, meron tayong 2 points. Pero dito, if we're going to represent your h po dito, ito na siya. x2 minus x1. The same with this one. If our x is equal to 3, and this is our 5, which means our h is equal to 2, no? Okay? So, the same with this one, no? Ito yung h po natin. Pag meron tayong nag-increment dito na h, we have 3 plus h. Figure 5, instantaneous rate of change of f of x at x is equal to h. Ibig sabihin nun, if your x is equal to 3, dapat yung value ng h natin is pareho lang siya sa 3. Kasi pag meron tayong point of tangency po dito, this is your second line, no? Pero yung tangent na line po natin is nandito siya. Ibig sabihin, we have only very little yung point of tangency niya. Kaya pag nandito yung point, yung solid point, yung 3 natin, saka yung edge natin is magkalapit po silang dalawa. So we have your example number 1. Find the instantaneous rate of change for the function at the given point. F of x equal to negative 2x squared plus 4 at 1 and 2. And your edge is 0.1. So ito yung difference ng point of tangency nila. Maliit lang po siya, no? 0.1. Okay? So dapat yung value ng x natin is very closer to x. Okay? So from our formula, y2 minus y1 divided by x2 minus x1. But from your tangent line formula, ito yung formula po natin na gagamitin. All over x po siya. So with that, the function of 1 plus 0.01 is your x1. Ito yung x1 po natin, ito yung x2 natin, no? So x1 is 1 plus 0.01 minus f of 1. Okay? So, 1 plus edge po na yun, no? Yan yung function ng 2 natin. 1 plus 0.1, 1 plus edge. Minus x1 is 1. Divided by edge. Huwag nyo na gamitin ito. Dahil ang formula natin doon kanina, divided by edge is 0.1. So, paano tayo nagkaroon ng 1.58 is negative 2? So, gagawin po natin, if we're going to substitute 1.01 squared, then multiply by negative 2 plus 4, the answer is 1.58. Tapos, f of 1, 1 squared is 1, multiply by negative 2 is negative 2, plus 4, we have negative 2, all over 0.1. So, we have negative 0.42 divided by 0.1. So, your tangent slope line formula value is equal to negative 4.2. So, that's our example number 1. We have your last example. Find the instantaneous rate of change for the function at the given point. So, we have the function of x equal negative 2x squared plus 4 at 1 and 2. By this time, yung increment lang po niya is 0.01. Ito yung point of tangency nila. So, napaka-close and close to our x. No? So, this is our solution. M tangent fx2 minus fx1 divided by edge. So, yung edge natin is 0.01. So, yung ano natin, if x2, if x1 is equal to 1 plus 0.01, which represents your x2, we have 1 plus 0.01 minus f1. Okay, all over edge. Paano tayo nagkaroon ng 1.9598? 1 plus 0.01 is 1.01 raised to 2 multiplied by negative 2 plus 4. The answer is 1.9598. Tapos dito, yung negative 2, negative 1 squared is 1 times negative 2 is negative 2 plus 4. The answer is 2. Okay? Divided by 0.01 is equal to negative 0.402 divided by 0.01. Your tangent slope line is negative 4.02. So with that, you can see now the difference between the slope of a tangent line and the slope of a second line. First, the difference there is yung point of tangency po niya, ito yung tangent line po natin. Yung second line, there are 2 points of intersection. Pero sa tangent line, isa lang po siya, and then the line is parallel to the given curve or function. Okay? At pagdating sa formula, ito yung difference po nila. Sa denominator, pag second line, delta x. Pag sa tangent line, we're going to use yung edge. Okay? So, that is all about the slope of a tangent line and second line. Thank you.